number sequence. What is a sequence? It's nothing more than an ordered list of numbers. There usually is some sort of a rhyme or reason of those. Okay. For example, let me give you the first one: 3, 6, 9, 12. 3, 6, 9, 12, and we have our little dot, 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 because they go on forever there. Please make sure you understand that these individual things are called terms. And it works a little like this. I can make little boxes here. Boink, a boink, a boink, a boink. In my sequence here, because the 3 is the first one, I call that the first term. Because the 6 is the second one, I call it the second term. And this would be the third term. And this would be the fourth term. If I asked you what the fifth term was, you would tell me it is 15. Because it just is. Now, with that being said, Carter Westphal, I can tell, usually when we block these off, and today we talked just a little bit about making formulas with these things. When we do formulas, generally speaking, we call the number of the term the letter A. Wait, let me make sure I'm right there. I'm sorry, the letter N, which makes sense because it's the number of the term. Okay. N is the number of the term, and the letter A. And the letter A, let me see what it is. A is what the value of that term is. A is the value. Okay. And a lot of times when you see this, you will see a subscript. Does anybody know what a subscript is? It's not a superscript. It's not a superman. Not a submarine. Evelyn, it is?
Words that are under the thing.
Yeah, okay, but we don't use words. We'll be using what numbers here. But yeah, if I say A to the 3, that doesn't, this is not like where you substitute a number in there. This is a subscript, just tries to direct you to what number you're talking about. In other words, okay, this actually asks me, what is the value of the third term? And you'd go look at our little list of things, and the value of the third term is 9. Okay. What is the value of the first term? It would be 3. Okay. This just it kind of identifies things. Well, you'll get more of that in some sort of advanced math. Now, if I gave you this, well, if I asked you to write a formula for this, that would work for me to be able to find any term, okay, which I show like this. A to any term. I can put any number I want into that. Oh, that's actually a term. What would you do? In other words, here's what you have to do is you say, well, what do I do to the top thing to get the bottom thing? Because if it's the first term I'm looking for, I take and I do what to it? Or the second term. Wade Davis says, multiply by 3. So A to any term is 3 times what? The letter N, right? Whatever term I have here, whatever my N was, I multiply by 3. Correct? Yeah, not so bad. Now let's go a little tougher here. By the way, let's throw this in here. Let me make sure I got it. When you see this, here's kind of the goofy thing about this. What do you do? What is, to go from one term to the other, what is happening? You are adding. Back in the day, you always used to say plusing 3. In 5th grade, everybody go, oh, plus 3, but now you're more mature, you say adding 3. interestingly enough, and think about this, if you add between terms, boys and girls, comma, it's a multiplication formula. Multiplication formula. Because look, even though we're adding between terms, what did we end up with our formula? It was 3 times n. So it's kind of good. People get a little goofy there because they see addition. I think it should be addition, but it's not. It's multiplication. This, an addition and addition type of sequence is called an arithmetic sequence. Arithmetic. I better look in the book for that one. I'm going to find it. Arithmetic. Arith. There's no E there? Who's the speller in here? Yeah, there's no E there. Are you going to tell me that? It's an arithmetic sequence. Well, if there's an arithmetic sequence, there must be some other sequence, correct? Just say yes. Why would we call one arithmetic and not another one? Take a look at this one. 3, 6, 9, 12. No, wait. Wrong one. 1, 3, 9, 27. 1, 3, 9, 27. Dot, dot, dot. Now, if I'm looking to find a formula, the first thing I do is box this up because I want to know. It just helps you to look at this. This is the first term. This is the second term. This is the third term. This is the fourth term. Okay. If I asked you to write the formula for that, what would you do? What do you do? What do you do to the n? A to the n equals what to get that value that stands for? What do you do to the n to get that? Morant?
Multiply by 3.
Is 2 times 3, 3? I like it when I smell brains burning. Nobody? Wow. Have I snubbed the 7th grade class today? Evelyn? Say it isn't so.
It isn't so.
These get a little tough to
Brent
think
said
about.
multiply by 3, right?
Does that work? 2 times 3, 3? Is 4 times 3, 27? It only works for this one, 3 times 3, so that's not the one. Now, what Brant was saying was part of what you think about, okay? To go from one term to the other, what am I doing? I am multiplying by 3 every time. But that's not part of my formula. By the way, the last one was addition, and we called it a geometric or arithmetic sequence. If it's multiplication, it is a geometric. And I don't know why they call this, I just give it to you because it's in the book. Geometric sequence. Now, I will give you a clue here. Anytime it's multiplication between the terms, it is, you use exponents some way. Somehow in your formula you will use an exponent. And then, let me give you another clue. Whatever number you are multiplying by, what number am I multiplying by? Whatever number you're multiplying is the base that goes to that whatever exponent it is. Guess what goes in that box?
3.
No, I already got a 3 there. Watch. Let me go back to this one. See? We had a 3, and what letter did we put there?
N.
Well, you're going to put an N in that box, except it isn't going to work the way it stands because watch. What is 3 to the first power?
3.
Okay, 3 to the first power is 3, which actually gives me that one. What is 3 to the second power?
9.
Which actually gives me this one. What is 3 to the third power?
77.
Which actually gives me this one. So this is almost right, except everything is one notch off. How could I fix that?
How do we fix that, Mr. Hahn?
What could I do to fix that so this formula actually would work for what I got going there? Evelyn?
Take a number out. And then just never mind.
Well, you can't do anything to move this. You have to adjust your formula.
Darn.
Well, let me ask you a question. If this up here wasn't a 3, but was a what, it would work? A 2, it would work. Or if this one wasn't a 2, but a 1, it would work. So what am I doing? To get this 3 to become a 2, what do I have to do to it? Subtract 1. So my formula is just 3 to the n minus 1 power. Because if I take n, which is 1, if I take 1 minus 1, I get 0. What is 3 to the 0 power?
1.
1. What is 3? If I take the second term and take 1 away from it, I get 3 to the 1. I get that to match up there. I get that to match up there. I get that. This is a little higher level than maybe. You just gotta kind of. It's not an easy thing to think about.
Not at all.
No, it's not at all. Let me see if I can find another one, just because it'll be fun for you.
Well, I can wait for you to see it's sticky piece.
But they don't seem to give me anything but. All right. Here's one. What if it was just this? 1, 2, 4, 8, 16. Once again, the first thing I do, if they're asking you for the formula, the first thing I do is put my numbers. This is the first term, second term, third term, fourth term, fifth term. And I label this. These are my n numbers, and these are my a numbers. And then I go, okay, a to some number. Then I think about what type of sequence is it? Am I adding to go from one term to the other, or multiplying? If it's multiplying, it's going to be an exponent equation. And what am I multiplying by? And whatever you're multiplying is going to be the base. You are going to have that too right there. You just need to figure out how to get your exponent to match up with what that is. So you think about 2 to the first power, which is up here. 2 to the first power, again, it's all 1 off. So what are you going to end up doing? Again, subtracting 1 from that. And that's going to be your thing. We're going to do one more because I think maybe you're starting to get this. Check this out. What if I go, let's just do this. 2, 6, 18, 54, dot, adada. And I ask you for Mr. Formula. So, here we go. What did I say to do first? Yeah, put the numbers above it. This is the first term, second term, third term, fourth term. You got to get that to match up with the bottom number. This is my n's, and this is my a's, and then I'm going to write now my beginning. My formula is a to whatever thing gives me this. Next thing you do is see how do you go from one term to the other. Carter.
Multiply by 3.
Multiplying by 3. So if it's multiplying by 3, it's geometric. And the 3 is the base of whatever equation I'm getting there. Now, you know that that's true. You're going to put an n up here. And I would just try. If I put a 2 in there, which is my second term here, what do I get? What is 3 squared?
9.
But what do I have?
6.
Let's try a 3. What if I put a 3 in there?
9.
Well, no, 3 times 3 to the third power is 27. What do I have to do?
Minus 1.
Huh?
3 times n minus 1.
Well, if you do n minus 1, I'm not sure that's going to work, but we can try. All right, let's say, so the first term, we try. Wait, well, let's see. Let's not give up on it yet. What is 1 minus 1?
0.
So 3 to the 0 power is, but I have a, so Wade says, well, hey, let's try the plus 1 here. Does that work for, will that work for everything? We might have to punt, because I'm not so sure this is going to work. Let's try that for the second one. What is 2 minus 1? What's 3 to the first power? Was 3 plus 1 6?
No.
It's only 4.
3 to the 6 minus 1 equals 6.
What's that?
I got 3, and then the n is 6 minus 1.
What n is 6 minus 1?
So, like, if you. The n is the. Never mind. I'm trying to think, but I'm confused.
Let's think about it a different way. Let's go back to that first one. Maybe if we figure this out. Let's go back to this one. Let's take away the minus 1. See if we can come up with something here. What if we did, let's do the 3 in there. Or maybe we should stop, because I'm not so sure I'm getting this one. I just know it has to be a 3 there. Here, let's do this. Let's go back to the one that we did know that was 3s. Right? What was the one that we did know that was 3? It started out being what?
1, 3.
1, 3, 9, 27, right? Alright. How would I get this to match up with that?
Because 1 times 2 is 2, 3 times 2 is 6.
Multiply by 2?
Well, from the top to the bottom, so you multiply 9 by 2, 18, you multiply 27 by 2.
Would that give me, so if I multiplied this answer once I got this by 2,
And
would I
squared.
keep getting that or not? What if I use the same equation and multiplied it by 2? Because it looks like this is everything, it's just doubled, is it not?
Yeah.
Well, let's try that. Let me change the formula to this. A sub n equals 3 to n minus 1. That was the formula that gave you this. And then whatever I get for that, I have to multiply by
Minus
2. Will it work? Let's try. Let's try the fourth term. If I put a 4 in for n, what's 4 minus 1?
3.
What's 3 to the third power?
27.
Times 2? 3, if I had the third term. 9 times 2. Okay, you did it.
What?
Kids.
More like you did it, we were just here confusing you.
They won't ask, by the way, they're not going to ask you to do that. I was just trying to get you to think outside of any boxes that you may be.
Box.
You won't have to worry about that, just so you know. I just thought since we were like